Hello. Second, all looks good. Hello and welcome. My name is Darko, and today I will try to show you how to get started with containers on AWS. This should be fun, right? And welcome to the stream. First off, I have a completely new setup. I have a new camera, new position, so fingers crossed this all works. So yeah, if something goes astray, do let me know. I think the sound should be okay. I tested that. The background music shouldn't be too loud. The last time it was a bit too loud. So hopefully today it should be a bit better. Excellent. Good afternoon, Graham. Pleasure to have you here again. So what is our idea for today? Today we're gonna attempt, or we're gonna have a look into how can you get started with containers on AWS. Hey, Kaurin, hi. The idea is to how can we get started with containers on AWS. So specifically, we're gonna have a look at Elastic Container Service, or ECS. So let's give it a go, right? Have a bit of tea. Okay, so but before I start, I need to shell something. So this Thursday, there's a Dev Day from AWS happening online. So a Dev Day is a more advanced level AWS presentation, or a collection of presentation. Think of it as an advanced webinar, where I will be delivering my talk on the topic of infrastructure as code. So if you're interested, I think this works. Yes, that's the link where you can sign up. You can also check out the additional talks we have there by my amazing colleagues, so I'm sure you will be enjoying it if you are interested in a bit more advanced topics. Okay, so with the shilling out of the way, you feel free to register. Again, if you cannot make it, it's going to be available online through recordings once we're done, so you won't miss it. Should be pretty fun. I had a lot of fun recording that. So, but yeah, let's move on to something. Looking at something, right? So let me switch to my screen. I think this all works fine. Excellent. The chat window should also be working above my head, so that's very good. Cool. So the goal of today is to have a look. Yeah. Hey, Kishametaka. Hi. So the goal of today is to have a look at ECS, or Elastic Container Service. Basically, the first steps a lot of people take when doing containers on AWS. So I'm going to just go through the basics of setting up a container cluster, creating a small Docker-based application. So it should be relatively simple and kind of like free-flowing. So first off, why would you use containers, right? So I always like to listen to people, or I like to hear people what they say when I ask, why would you use containers, or why do you use containers? Unfortunately, a lot of people told me because my company wants to move to Docker, or because it's the thing right now. You know, using containers, you should have a proper reason to do so. Especially, you know, switching from a more monolith approach to a service. Hello, Waples. Hi. Moving from a more monolithic application approach to microservices. That's one of the reasons you might want to use containers. But microservices are not necessarily containers. So if you use containers, you can have a monolith running in a container. You shouldn't, but you can. So using containers is not the only way to break up a monolith. So, but in today's case, we're going to create a monolithic application, which is going to be a very simple application, as you'll see. And it's going to be running on a container. Hey, Dennis. Hi. It's going to be running on ECS. So let's give it a go. So the outline of today is going to be, I'm going to create a Docker application. I'm going to create all the necessary things in the backend to run my Docker application. And I'm going to configure it all through ECS. So there's kind of multiple flavors of containers you can run on AWS. Usually people opt into either using ECS or Kubernetes. Now, Kubernetes is great, right? But it's complex, right? It's much more complex. If you want a quick and dirty way to run containers, ECS is the way to go, right? It's a very, well, a relatively simple service you can use to get you right up and running with containers. So what is ECS? Well, Elastic Container Service. It's basically an orchestrator for your containers, and it kind of consists in a few things. And before actually, I want to show you this how you look at it. So when I joined AWS, when I started using ECS, because I started 4 years ago in premium support, and one of the services I was supporting our customers was ECS. So one of my first trainings was ECS, and the person who explained me ECS was telling me in such a way there are 4 levels to ECS. There's a task, which is defined by a task definition, and that task is run through a service, and that service sits in a cluster, right? So you create a cluster, you create services, those services run tasks, which are made from task definitions. So that's how you do it here. So what we're going to create here is, well, first and foremost, we're going to create a container or a Docker image to run some silly application. Then we're going to create a task definition, which basically is a thing that defines our task or how our container will run. Then we're going to create a service out of that task definition and telling it, hey, this task definition, make sure to execute these tasks within my service, and then that service is going to sit on a cluster, and a cluster in this case is just going to be a bunch of EC2 instances that will run our containers, right? So there are still existing EC2 instances in our AWS account, but hopefully there's some other ways to approach it as well. So let's create this application. So let's create a Docker application. Anybody in chat ever create a Docker application or a containerized application? What's the first thing you do? So I have an empty directory here. What's the first thing I should do when creating a Docker application? Nobody? Well, you can start with an application itself. I have no application, and let's install Docker. Absolutely, but I have Docker running, so Docker PS exists. I have Docker installed on my MacBook, and you can actually see it here, the whole thing. So absolutely, you need Docker locally to start with it, but create a Flask app. I'm gonna go a bit simpler than doing Flask. I'm just a simple man. So let's start with let's create a website, right? So mkdir website. And Vim website, and let's do index HTML. Yes, let's create a web page. So I am actually gonna go on and paste a bunch of HTML, and this is it. This is my web application, technically. So it's just a simple HTML file, nothing special, just a simple dummy HTML. So this is gonna be my application. Now, you would never run a static HTML website inside of a Docker container because there are much better ways to do it. So imagine this being a bit more dynamic. Imagine this being a Flask app or running in PHP or something else, something more dynamic that you actually need a container for something like that. So I've created my application. Now, technically, I could run my application by opening this HTML file in a browser, but let's imagine that we need something more in the back. Let's imagine we need PHP and Python and whatever. So to create all this environment, you need a web server to run it in. So what we are gonna do here right now is we're gonna create a container that's gonna have a web server running within it, and that's gonna basically host this HTML file. Simple as that. So what we need to do when you start working with Docker is you need a thing called the Docker file. So let's create a Docker file. Docker file. So the Docker file in itself is going to basically define commands and elements that our Docker images are going to contain. So this is going to be a super simple Docker image or a super simple container, which is just going to contain Nginx, and Nginx is the web server, right? So we're going to be using the Nginx web server here to host our web application, and we're going to copy the index.html file we have created just before. So how do we get started with Nginx? I just do from and just Nginx. So this will tell Docker to pull the Nginx image from the Docker repository, basically from the repository where these images are located in. So basically, it downloads all the things it needs to run Nginx for you. So these are pre-built, so I've not done anything with Nginx. These things are pre-built and are already sitting somewhere in a Docker repo. Once that is done, I just need to do copy. So I'm basically telling Docker, hey, once this is done, copy website, or copy the directory called website to USR share. So USR share Nginx HTML. So copy the contents of the website directory to this directory. And that's it. So basically what this will do, it will copy the index HTML and any other files I might have there into USR share Nginx HTML on the container itself. Because in essence, container is running a, I think a bad, it would be a bad term to say a minimum version of Linux, but it kind of does that. It has its own directory structure with certain limited elements into it. So it's and of course in this case it has also Nginx running in here. So Waples asks, quick question, in between, would you rather use an example Nginx Docker images from Docker Hub or just build your own and host them in ECR? So in this case, I'm building my own image, but I'm using Nginx, the Nginx image from Docker Hub. So the from Nginx is basically gonna pull Nginx from the Docker Hub. But once that is done, once I build my image, I'm gonna push it to ECR, or the Elastic Container Registry. Think of it as a private repository for your Docker images. And I'm just gonna put it there. I could also build it myself completely. So I can just, instead of using from Nginx, I can use from Ubuntu or from whatever, Debian, and then install packages manually. But using from Nginx is a very simple way to explain it. So excellent. So saving this like that. Excellent. So what is the next thing we need to do? Well, we need to build this file. So if I do docker build.net, let's call it, let's tag it with, so it's this. I'm gonna tag it with stream website. So defining the -t there means I'm tagging the image being built as stream website. So the dot presents within this directory. So it's gonna basically look for a Docker file locally and do all of that stuff. So if I do this, it's gonna pull Nginx. So it's gonna pull down the file systems, everything you need. And it's around 50 megabytes for Nginx in this case. And we can see that it has downloaded the Nginx latest image. And it also ran the copy command, copy the website, basically all the contents of my website directory into here. So if I would run docker images and I will see that I have all the images, including the Nginx image. So it has downloaded the Nginx image, well, before, because I used it already here, and it has the stream website, which is the image I've just created. Excellent. So what can I do right now? I can actually run Docker. So if I do docker actually run -d, not rud -d, and then define the port. So I'm gonna just use local port 8080 and define the container port to be 80, and run the image called stream website latest. So I'm running this tag. So hopefully this works. Unable to find website stream webby. Oh wow, there you go. Let me just fix that. Docker images. Oh, the Minecraft tags? Yeah, there you go. I have a lot of toys and video games in that little shelf over there. Yeah. Docker image rm. Let me just remove this image because I want to create a new one. I have made a typo here. So, okay, excellent. Again, build. Let me web site. See, it was much faster right now because it didn't have to download the Nginx image because it was already present here. Let me then run it. Cool. So if I do docker ps, we will be able to see that I have a container running. So if I do curl localhost 8080, I have a website. Or even if I do this, if I do localhost 8080, I have my web application running. But that's not why we're here. We are not here to watch me running containers on my laptop. We're here to see how can we actually deploy this application to the cloud, right? So, and one of the added benefits of containers, like if it works on your laptop, it most likely will work in the cloud. So how can we transfer this experience to the cloud right now? Well, the first thing we need to do is we need to create a repository for containers, right? So if you go to services and just type ECS, go to Elastic Container Service, on the left-hand side, you see ECR repositories. And get ready to see this amazing consistency of design in some AWS console elements. So this is the current console. If I click here, completely different. So some things are kind of not consistent when it comes to design. But yeah, that's picking up as well. Okay, create repo. Let's call it stream website. Awesome. And I'm just going to create a repo. So this repository is going to be used for me to upload my images. Now, how can I do that? Well, simple. Select this and see do push commands. So ECR will tell you which commands you need to run to push your image to the cloud. So, and the first thing you have to basically do is you have to log into this repo. And it's going to use the local AWS credentials within your workstation. So if you have AWS CLI installed, you have to have AWS CLI installed. In this case, it will basically log you into the repository by using the Docker login. So running this, hopefully login succeeded. Excellent. Now I'm gonna build this again. I mean, it has been built already, but I'm just gonna do it again for the sake of consistency. So, but here's one more thing. So one of the things I don't agree with. This command tells you, hey, this is how you should tag your image. But I want to do something else. I want to make sure to change the tag from latest. I'm going to do version 0.01. Using the latest tag is okay, but it's not good for production, because if you just use the latest tag, something can go wrong with the latest tag. And if you keep on updating just using the latest tag, it's sometimes very difficult to go back. So version pin, make sure you define the versions like so you will be certain of which version you're running. It's not just latest. And it's much easier to kind of switch between versions. So that's my advice. Some people would argue, but yeah. So doing that, okay, I have tagged this. Now the next command is the Docker push. So what I do here, instead of just latest, I'm just going to define the version 0.01. And wabam. So this will upload the images from my laptop to the ECR repository I've created in the step before. Work? Yeah. Takes a moment. So there, excellent. Blessed be fast internet. Okay. What now? Yes, let's go back to the repository, and if I open the repository, we will see that I have my image uploaded with the version 0.01. Excellent. That is good. We are good to get started. Now, to run this, we need to do something with ECS. So we need to create the cluster. So we need to go into clusters and create a cluster, and this will be the platform where we will host our containers on. So again, different design. Lovely. Create cluster. I'm going to be using EC2 Linux plus networking. Now, you can use networking only. This will create everything you need to run Fargate. Now, I have not talked about Fargate, or I haven't talked about the hosting options. Well, let me actually have a proper look at you. So I have not talked about hosting options for ECS. So there are, in essence, 3 ways you can do container hosting on ECS. So there is the standard one, running Linux on an EC2 instance within your account. There's another second one, very similar, but instead of Linux, you can use Windows as well. And the third one, the latest one, is by using Fargate. Now, Fargate, think of Fargate as serverless containers. So these, you basically pass us on the image and say, hey, just run this. I don't care, run this somewhere in the black box of the internet. but in essence, you don't have to care about having any resources. In a sense, you don't have to have EC2 instances provisioned. You don't have to manage those EC2 instances. So in essence, it might be much more simpler, but it's a bit more expensive than running just EC2 instances for your own. So a combination of Fargate plus EC2 ECS clusters is the best approach as of now. So that's why. So in this case, I'm going to show you the more complex way, or I'm going to show you how to use EC2 instances in this case. But if you use Fargate, it might be a bit simpler. So let's move on. So I'm going to choose, oh, by the way, you can also use Kisha Metakas. If it's more expensive, what are the pros and cons of Fargate? The pros of Fargate is you don't care about anything. Literally, I would just say, hey, you know what? This is my image, just run it, right? On EC2, you have to have an EC2 instance running within your AWS account, which means you have to patch it. You have to make sure that it's up. You have to, you may pay for, let's say, you will have more idle time than running Fargate, because Fargate only runs your container, and once your container is gone, you don't pay anything. It's basically like serverless, right? So you only pay for your container as long as it's running. As soon as your container is away, there's no lingering resources. There's no idle resources like Lambda. Yeah, think of it as a Lambda for containers. Exactly. Yes. Graham, no, EC2 are not more expensive in this case, because EC2 instances, especially if you use things such as reserved instances or reserved capacity, it's much cheaper. So let's say you have a web application that you host, that you have a kind of you have a defined load. You understand that this is the baseline. I will always have this amount of load. I will always need 8 containers running in my service, right? What you can do, you can purchase like the reserved instances up to like between a year and 3 years, and that can get you 75% savings. So you can have massive savings on compute if you use EC2 instances compared to just using Fargate. But you might have idle resources. With Fargate, when you scale up and down, it's basically like Lambda. It's much slower. Don't think of it as Lambda, but with Fargate, you basically spin up a container. Once you are finished with the container, it just all goes away. So, there you go. Oh, congratulations, you have the certification. Very good. So, okay, so what I'm gonna do, I'm gonna actually create an EC2 instance, and I'm gonna create an auto-scaling group with EC2 instances that are basically gonna be my my cluster. Also, besides just running it on an EC2 instance, you can run your container on anything. So technically, if I would take this, a Raspberry Pi, install the ECS agent on it, I would technically be able to run containers on this one as well from ECS, because ECS don't care. As long as it has an agent that's compatible with the platform and is able to communicate with AWS, you can run your containers on this one. So it's very flexible. So if you have extra capacity locally, you have some servers, you can also include them into running ECS containers. But I have not prepared my Raspberry Pi for this, so yeah, I'm gonna skip that. So Waples, yeah, it's a cluster. Absolutely, you can run multiple containers on a single instance. You would use a cluster because there are only so many resources you can use on a single EC2 instance to be able to distribute, right? So I can maybe run 5 or 6 containers on a single EC2 instance. If I want more, I need another instance. So and having at least 2 instances and 2 containers split across these 2 instances is great for high availability. So is there any additional cost if you use on-prem servers? See, that's a fair point. I wouldn't know. So that's something I would need to check. I'm not sure about the pricing when it comes to on-premises. I know some services like CodeDeploy. If you use CodeDeploy on premises, you have to pay extra just because it's on-prem. But for ECS, I'm not sure, because the ECS pricing is, I believe ECS as a service is free. The only thing you pay is for the hosts running on it. So ECS pricing. let me just have a look. Fargate, EC2. Yeah, exactly. You're not paying for the host, but I don't think there's any additional cost. I mean, so in essence, it doesn't say here that you can use anything else, right? So it doesn't even say you can do it on-prem, but to be fair, see, that's a great idea for one of the other streams. I'm gonna actually see if I can do this with my colleague, and we can do some fun things with ECS and on-prem and do some crazy stuff with it. In essence, it shouldn't cost you much, right? It shouldn't cost you anything because you don't pay for those resources, and apparently there are no maintenance or operations costs outside of that. So again, it's not ideal. I would not recommend you to do that. It's more of a, hey, if you have spare capacity, fine, but you're splitting things up from latency wise. It's, you know, you cannot put those things on behind a load balancer. There are 1,000 things that can go wrong here. So it's more of a, for me in this case, it could be more of a novelty. But yeah, save it for AWS Online Dev Day session. Oh, that would be interesting. That would be a big dev day. Yeah, I'm not the massive expert on containers, but I'm always happy to try. Okay, let's actually create a cluster now. So EC2 Linux networking. I'm just going to the next step. So this is actually going to create that auto-scaling group. So let's call it stream website cluster. Right. I will use on-demand instances. So yeah, you can use definitely you can use outposts, right? Outposts are fully managed racks sitting in your data center, which are managed by AWS, and you can launch AWS resources on them. But I believe, I have not tried this, that you can also, yeah, exactly, $8,000 a month, and I think there's like an upfront cost of, it's expensive, right? But if you need a rack locally to run AWS, there you go. But yeah, it's expensive, yeah. But I really want to try to position ECS on this one, but maybe some other time, as my lovely Raspberry Pi is not functional at this moment since the last time I played with it. Okay, so let's create auto-scaling group in this case. I'm gonna go be a bit frugal and choose my E3 instances. I'm gonna say I want 2 instances. And here's the thing, it's gonna all pre-choose the Amazon Linux AMI, and this AMI is optimized for ECS. So it has the ECS agent installed on it, and you can already use it out of the box. Storage, let's add it a bit more. I'm gonna use a key here as well, like that. Okay, let me add it to my VPC. This is a good subnet. Choose the one without math. This is okay, and this one. Okay. Okay. Now security groups. Let me choose a security group for these instances. I think I have a created one here. There's some SG called ALB something. I will select this to be a container instance role, and the tag shouldn't be one. I'm going to enable container insights. Container insights basically send a lot of more information monitoring to CloudWatch, so it helps us to do things. So I'm going to just enable that. That's it. So this will basically create a CloudFormation stack running with ECS cluster, well, an auto-scaling group behind it, and we're going to be using that auto-scaling group as our ECS cluster. While this is happening, I just want to have a look. Fine. Excellent. Cool. This is running now. So if I go to view cluster, this should be fine, right? So I have a cluster. If I go to ECS instances, you will see in a moment or so, until those instances boot, you will see that there are two instances, container instances, which are ready to accept containers. And I talked about capacity a bit before. See the CPU units available and the memory available. So this is the capacity I was telling you about. When you define a container, you define how many compute units it takes and how much memory it takes. If it cannot fit on a single instance, it will use a different one. So that's why you might have multiple ones. Yeah, Maples, a lot of things internally use CloudFormation. CloudFormation is this big glue that makes everything work together. So it's amazing. It's just a simple way to deploy a bunch of services, and a simple way to destroy them as well. So, you know, imagine if ECS was, instead of creating a CloudFormation template, imagine if it was just making a bunch of API calls somewhere. Then it would also need to track what has it created and how to delete it. You know, the whole point is do not try to recreate the wheel. So, all right, a message beep up on me. Okay, this is good. Now, once we have this, it's time to create something else. So we need to create a service, but before we create a service, we need to create a task definition. The task definition is basically this thing that defines, see, I already have one here, but I'm gonna just ignore this one. Can I delete it? I have to do it like this. That. So this is from my testing earlier. Register wheel. So the task definition actually defines how our container is going to be launched. So I'm going to pick EC2 in this case because I'm going to create an EC2 instead of Fargate task definition. Let's call it. So stream website task def. I'm going to give this a role. So basically you're giving your tasks, the containers that spin up, specific roles. In this case, it's optional, right? You don't have to do this. But for example, if you want your containers to read off S3 or write to S3, you would give them a task role with those permissions to do so. Network mode, I'm going to leave it default. So these are using the basically Docker built-in networking. So I'm not going to do anything here. Task as execution role. So this is basically giving the ECS, it's kind of a service role to publish logs on your behalf, etc., etc. Now the tasks, how much memory they're gonna take. Let me just define, I want to just 256 megabytes is fine. CPU units, I'm gonna just do 124, and 1024 is a single CPU unit. So 2 virtual CPUs or 2 cores is 2048, right? So I'm just gonna use in this one. This should be fine. And once you define this, you need to define a container. Now the container is the actual thing that, well, your application in this case. So let's call it stream website container. Last time I wrote CNT and somebody told me it's not the proper word. It could be misinterpreted. So I need a URL here. So how to get that URL? Well, let me actually go this console. Let me go to the registry, and in the registry I can just go here and then click on this little thing, and then bam. So I defined basically my image with its tag that it's going to be using it. Memory limit, I'm going to just set to 256. That is fine. And the port mappings, I'm going to put 0 and 0. So why am I doing this? Is basically it's going to use a random port for the host. If I would define port 80, that means that my instance would listen, and my instance will actively, well, sorry, my container would actively listen on port 80, and it would, in essence, it would occupy port 80 on my EC2 instance, which in turn means that I can only have a single container running on that instance. So if I just define 0, it is gonna use a random port. So which means that I can have multiples of the same type of container running on a single EC2 instance. Now you can do a whole bunch of things here, from health checks to defining amount of CPU units, if you want GPUs, entry points, some timeouts. I'm going to completely ignore all of this. Now this might be very useful. Logging. Yeah, there you go. Yeah, the port mapping is very important. And I in the past it was not possible to use different things here. You had to define it, so you could technically run a single port on a single instance, which was bad. So one of the things that might be useful here is like defining logging. So you can do log configuration by using a specific log driver. You can use AWS Logs or Journald or Splunk or Sumo Logic, syslog, and basically this is where you would ship logs somewhere else. So I'm gonna well, let's do this. Why not? So I'm gonna use AWS Logs. It's gonna ship logs from my container to CloudWatch. Security, Docker labels, nothing. Just click add. Hopefully. Did I do something wrong? Missed something. Sorry. This has to be 0, 80. So the container port has to be something. So the host port should be 0. The container port needs to be an actual port. If it has to be pointing to Nginx running on there. So add. Attaboy. I'm gonna completely ignore the rest of these things. You can do, service integrations with service or app mesh. I can add some additional volumes and tags, but I'm just not gonna do it here. So click create. Excellent. So we have defined a task definition now, and since we have a task definition prepared, we can go ahead and create a service. So going back to the cluster, what we need to do is, I need a load balancer. So before I continue, I need to create a load balancer because I'm going to put my containers behind the load balancer. So to create a load balancer, we're going to use an application load balancer in this case. So I'm going to go down to load balancing. I'm going to create a load balancer. I'm going to use the application load balancer. Create, give the name, stream, website, ALP, 480. Let me just use a proper VPC in this case. This should be the good one. This should be the other one. Excellent. Now configure security settings. I don't need anything here. I want to just use this security group, right? This should be the good one, I think. Yeah, that should be the one. Configure routing. I'm going to create a target group called ECS website, and I'm just going to leave it like that. I'm not going to register any targets because I'm going to leave the register targets part to ECS. Review and create. Excellent. So now I can use this load balancer within ECS to basically host my containers on it, or sorry, host my containers behind it. ECS. Okay. I have my cluster here. Let's create a service. Click the create service button. I'm going to select EC2 as a service name. This is the only task definition we have here, so I'm going to choose that one. I'm going to use the latest revision, or revision number 1. It's going to be launched in the stream website cluster, and I'm going to call this name a service stream website SVC. Now there's two types of services you can have. You have replica services and daemon services. The only difference between those two, daemon services can only have a single per instance running. So daemon services will be only existing one on an instance. And if we look here, it will say daemon services place and maintain one copy of your task on each container instance. So you cannot have multiple daemons running on a single instance. So I'm going to use replica in this case because I don't really care about any daemon. So the number of tasks, I'm going to say 4. So I have 2 instances. They have 2 virtual CPUs, and my container requires 1 virtual CPU to run. So I'm going to use rolling deployments. I'm not going to use blue-green. If I use blue-green, it's going to basically provision containers. It requires co-deploy. I'm going to completely ignore that. Placement, I'm just going to make sure that it balances the spread across multiple AZs. And the next step, I'm not going to include service discovery because you can use service discovery through Route 53, but I'm going to completely ignore that. Application load balancer. Now, we have our load balancer here. Excellent. So I've selected this one. Now I need to add a container to a load balancer. So basically, I have only a single container running in my service, or in my task definition, which is called stream website container, and it's listening on port 80. So if I select this one and click add to load balancer, that should be fine. So I just need to select a target group, this one, and this should be okay. So it's gonna use this existing target group, port 80, and that should be fine. So it will take the random port it makes, and it's gonna be working fine. Clicking next step. I do not wish to adjust the service count. Now you can do this as well. You can create service auto scaling, but in this case, I'm just gonna leave it as is, because nobody had time to set this up and wait for this to work. Click create service, and yeah, it creates a bunch of IAM stuff if it needs. It's gonna create the service itself. It does not create pipelines or anything like that. By the way, people in chat, is my voice lagging? So the camera I have is running off USB. Apparently there's a slight voice lag between me speaking and the video coming in. I had to manage this somehow in the audio mixer, so I tweaked it a bit, but I'm not sure if it's as good as it should be. So just submit. Okay. Quick question on the auto scaling. Does ECS support memory metric alarms? So thank you, Wavels. Are you talking about auto-scaling EC2 instances? Or just the services? So EC2 instances, in essence, the memory metric doesn't exist by default. So you have to create a memory metric. So you have to, on EC2 instances. EC2 instances do not ship memory by default, because that's an OS thing, and you cannot read RAM outside of the OS, or RAM usage outside of the OS. So you would have to ship that thing to CloudWatch, and then based off of that, you can create an alarm, and then it works. So auto-scaling is great because you can literally trigger any kind of alarm to scale up or scale down. So it can be any arbitrary thing. And actually, my last stream was about the talk of metrics and telemetry and all those things. So you cannot attach the alarm to your auto-scaling group. That's interesting. How can you? Yeah, it doesn't matter, but you should be able to do that. So your auto scaling groups. Let me just go a bit off topic here. So auto scaling groups. Here it is. Scaling policies. So I don't have a scaling policy. One of the things I can do here is let me switch to the new console. I think new console is a bit better on this thing. So this one, automatic scaling, add policy, simple scaling, and then I can just basically select any CloudWatch alarm I have here. And if a CloudWatch alarm would trigger because, I don't know, I pressed the button, it would do that. So any CloudWatch alarm can go in here as long as it's an alarm you created, so it should work. Okay, back to ECS. Okay, now what I see here, once I've done this, I see 4 containers or 4 tasks running. So again, cluster, service, task definition, task. So I see these things running here. And if I would go to my load balancer, oh, that's it from when I started. Yeah, there's differences between the old and new console. The new console is much more streamlined, and I think it's much more easier to work with. So. And here's the thing, if you think something can work and you don't find it on the web console, the CLI most likely supports it. So yeah, let's have a look. So let's see if this works all together. So if I go to listeners, if I go to targets, I will see that they're not healthy. Why are they not healthy? Target registration is in progress. So it's still initial. It takes a moment or so, but why were they draining? So is this not working properly? It should be working. Okay, let's go back to here. All scaling groups, not all scaling groups, load balancers. Load balancers, Darko, load balancers. Let me see if this works at all. I think I will get a 40504. Yeah, it doesn't work. There you go. The new console is better, right? So it shows as unhealthy. Request timeout. So here's the thing. there's a timeout. So I am sure that this is a security group problem. So let's have a look at these instances. And what kind of security groups are these instances sitting in? So ALB Web Access has inbound rule of 80 from anywhere. But let's edit those things because I want to add a rule called custom TCP from ALB. I will add, basically, I'm adding anything here from any port from the same group, because I need to allow the load balancer to reach any port, and you know, the random ports I told you that it's going to be using, we need to check is it healthy or not. So we need to allow the load balancer to check are they healthy or not. So if I do this and save rules, I think this should be fine right now. So going back to my load balancer, so listeners, this one, it will take a moment or so until new ones show up, because it's training. It's gonna attempt to re-register once. Once these ones, yeah, they're all draining. I didn't select the security group, you think? Really? Again? LB Web Access? I did. It's here. It's SG, yeah. It has basically from any port, so it should work now. Again, load balancer, ECS. So it's on the initial phases, so it takes a moment for it to register. Again, it's the health check, and yeah, that's fine. So let's make sure this works. So Kishametaka, you told me you passed your solution architect associate exam. Was it difficult? You're unhealthy. Excellent. Not really. Yeah, it's relatively simple. I think it's a very cool. It might have changed. Yeah. I have, Graham. I have mine since 2 years ago. I think it expired already. So there you go. It's not the best example, but mine expired. I just have the associate one, so I did not go any further. Yeah. B42, is this the same one? I need to add this same one. Yeah, it's the same as the security group. Oh, fingers crossed. Hope you get it, man. Okay, this looks good. Yeah, so once you do the solution architect associate one, the other ones are very similar to it, so it's easier to pass them. I was just so lazy to do it, so not the best thing in the world. Just do, no, not custom. Can I do all to TCP? Okay, there you go. Haha. Yes, port 0. There we go. It should work now. I apologize for live troubleshooting. I don't wanna waste your time. So let's check this again. Yeah, it's always fun playing it, but exams are not fun. Even myself, when I did exams, it was not the funnest of things. Even after like 2 years of actually doing AWS, it was also an exam. Okay, we see healthy. That's very good. So instead of getting a 504, I should get my application now. Excellent. This is running in a container. Woo! I have my containers now spread across 2 EC2 instances. in this case, right? So I have where they are. So I have my 4 tasks running against multiple EC2 instances. Now again, I have only 2 EC2 instances here, and yeah, I can fit 4 tasks on it because of the CPU constraints. Now, how do you update your application? So let's say I want to change my application to something else. Let's actually change this. Do we have some time? We have a couple of minutes. So let me website index HTML. This is running a container version 0.02 alpha, right? Excellent. So let's save that, like exit like that, and then what I need to do, I need to run docker build again, docker build. Then I need to docker tag. Where's the tag one? I'm gonna use the latest one again, target as 002, and then docker push 002. Attaboy. So it pushed this change off to ECR. If I go back to my container repository, I should see that I have tag 002. Perfect. Now back to task definition. If I click here and click create new revision, I'm gonna basically relieve the same thing here. I'm gonna change my container definition to use 0.02, update, create. Excellent. Now this has been updated. Go to cluster, go to my cluster, select my service, click update, use the latest revision, next, update, and now this should hopefully update my my service with new running tasks. Now, one thing I might run into here is that it may not actually be able to do it because I have no more compute capacity. But let's have a look. So we can see that these are running the older version, so the the first version, right? So we are waiting for them to update to the latest version. But yeah, so here's the problem. It will not replace the containers unless, so no, it doesn't automatically drain. It basically it will create new ones to replace the existing ones. So this is why always you should have some extra capacity. The way I can do this right now is I can go to my autoscaling group. If I go to my autoscaling group, hence the autoscaling group, and I can just go here and manually edit. Of course, you could have do this with automatically, right? But I'm gonna just be a pleb and do this manually. Add 4 and then more 4. Save. Of course, you shouldn't have double capacity available. You know, just one extra would be sufficient, but let's go overboard. And see, it will fail to place the task because it couldn't find any room to do it. And it will not terminate these ones because it wants to maintain to have all of them there. So, and the deployment here, yeah. The minimum healthy percent is a 100. So if I change this, for example, to 50%, it might take away a few of these containers as well. So we go back to cluster, right? Let's see how many ECS instances we have. So far, we have a third one spinning up, right? So we have one. We can see that the availability of the CPU is 2048. So we can have 2 additional containers run. And if I go to my service, hopefully at one point we will get more services being launched. Yeah, eventual consistency. Cool. Excellent. Come on, I'll give it a minute or so. Yeah, Kishametaka, A Cloud Guru is great. I actually used A Cloud Guru for myself to get ready for the exam, so I can highly advise it. So Has anything changed here? Shall we give up on this? Yeah, in essence, what's going to happen now is we're going to have containers being deployed within the latest version. Well, we're going to have tasks being deployed with the latest version of it as soon as it has the capacity to do so. So at this moment, it doesn't yet have capacity to get that, but yeah, we will have that in a moment or so. Okay, so yeah, that has been an introduction to ECS on AWS. So basically, how we can get started with containers. Very simple. I mean, it did look a bit complicated, a lot of moving parts, but once you get started with it, it's relatively simple to run your container applications. Of course, you will have much more complex setup than this. You will not have a single EC container running with a single HTML file. You would have most likely multiple services or multiple tasks with tasks with multiple containers on them as well. So it will be much more complex. So things such as service meshes and those things come into mind. And especially, I cannot cover all of that in 1 hour. So anyway, it's been fun. Thank you very much for joining. Don't forget about the Dev Day I mentioned before. I'm not sure if I can paste the thing again here. Like so. Can I paste the link? I don't have the link. No. Check out the Dev Day if you want on Thursday. Also on Thursday I'm streaming as well, so at the same time I'm going to be streaming. I am going to stream AWS Config. It's a service coming from the management space on basically auditing configuration changes on your AWS account. Very cool, very useful. So hopefully I'll see you there. And my name has been Darko. Thank you very much for joining, and I will be seeing you on Thursday. Bye-bye.